A ladder 10 feet long rests against a vertical wall. So let's draw that now. We have a vertical wall, say this one. So it is perpendicular to the ground. So I draw the ground too. Say this is the ground. And this angle is 90 degrees. Here's the hole. We have a ladder. Say this is a ladder. And this ladder 10 feet long. If the bottom of the ladder slides away from the wall, so it slides away like this. So for example, one situation is, say this one, but now it slides away like this, for example. So that is what happens. So let's say this length is x, the length between the base of the ladder and the wall. So from the bottom of the ladder to the wall, this length is x. So x keep increasing. So when the base is here, x is longer. And the bottom ladder slides away from the wall at a rate 1 foot per second. So this means that x changes 1 foot per second. Dx over dt equal to 1. That's what we know. How fast is the angle between the top of the ladder and the wall increasing? So this is the angle they are talking about. So let me call it theta. Theta is increasing. This angle is smaller than this angle. So the angle theta keep increasing. And they ask us how fast is the angle between the ladder and the wall increasing when the bottom of the ladder is 6 feet away from the wall. So the bottom ladder is 6 feet away from the wall. That's the moment they consider at x equal to 6. They ask us to compute d theta, how the angle change over time. So let's do that. We need to set up a relation between x and theta. So we look at this right triangle. You have this angle theta, relation between theta and x, sine theta x over 10. So this is our relation. And all we need to do now is differentiating and then plug in the values they give us. X and theta are function in terms of t. Remember that. D over dt, differentiating both sides, you have sine theta equal to d over dt, x over 10. So psi prime cosine theta, remember this, we need you to change rule. D theta over dt, theta's function in terms of t. Right hand side 1 over 10, I can move it out. Dx over dt. And now they gave us dx over dt is 1. So this term we know. Dx over dt is 1. That's the first thing we know. The second thing we know is that x equal to 6. And we also know the relation between x and theta. X equal to 6. From this relation, I can get sine theta 6 divided by 10. So 3 divided by 5. So that's one, we have sine theta. Now it doesn't look very nice to me, so I just compute cosine theta from that. So remember that theta is an angle between 0 and pi over 2. And sine theta equals this. And therefore, cosine theta is positive. We are talking about the angle theta between 0 and pi over 2. And note that theta between 0 pi over 2 sine theta cosine theta both non-negative. That's what we use here. So I have cosine theta square plus sine theta square equal to 1. So I use this to compute cosine theta. 1 minus cosine square theta, 1 minus 3 over 5 square, which is 1 minus 9, 25. This is 25 minus 9, 16 over 25. This is cosine square theta. And therefore, I can do square root both sides. Cosine theta, we know it is non-negative, so I don't need to have the absolute value here. Square root of 16 over 25, 4 over 5. Cosine theta is 4 over 5. That's one we now know. And everything is known. And therefore I compute d theta over dt. At the time x equal to 6, we have at x equal to 6, cosine theta 4 over 5, 4 over 5, d theta over dt, what we need to compute, 1 over 10, dx over dt, dx over dt is 1, times 1. So d theta over dt, 1 over 10 times 5 over 4, which is 1 over 2 times 4. I cancel this 5 out, so I have 1 over 8. So the final answer is d theta over dt is 1 over 8. That is the rate how fast the angle is increasing. D theta over dt is 1 over 8.